Hello, my name is Freeborn Goodluck Otuya.
My name is Gabriel Stanley Chukwukalibia.
Welcome to Studysmart, where you learn faster and retain more.
Welcome to Studysmart, where learning meets ease.
Please like, share, subscribe, and comment. Study smarter
and not harder.
Okay, types of sets. We have various types of sets. We have the empty set. We have the empty set. In empty sets, this empty set involves an empty set is a set that has no element. A set that has no element. As the word implies, empty. Something that is empty means that there is nothing inside, right? Okay. So now, an empty set is a set that has no element. And it is being represented by or you can either represent it in this form or you represent it in fire. This is fire. This is fire. PHI, fire. The Greek symbol, fire. So you can either represent an empty set using this or this. The second type of set we are going to be talking about is the finite set. Finite set. A finite set is a set that has a limited number of elements. A limited number of elements. So what that means is that I can have A to be equal to set of these values 2, 4, 6, 8, and 10. This is a good example of a finite set. It's a set that has a limited number of elements. This is a typical example of it. And then we are going to be talking about the third type of set, which is the non-finite set or the infinite set. Infinite set. An infinite set is a set with unlimited number of elements. A set with unlimited number of elements. For example, a set of all natural numbers. So if I tell you to list out all natural numbers, I'm going to count 1 to anywhere that you want to stop. You know, you cannot, if I tell you to count up to 1 trillion, it is very hard for you to do that. By the time you count 100, you proceed to 101, till 1 million, you proceed just like that. So if I'm telling you to write a set of all natural numbers, a set of all natural numbers is a very good example of an infinite set because it has an unlimited number of elements. For example, if I have A to be equal to set of all natural numbers. And what are the natural numbers? We have 1, 2, 3, 4. In continuation, if you want to continue the numbers, you represent them by adding 3 dots to it, which means that these 3 dots simply shows that this number continues, okay? It shows that the number continues. So that's a typical example of an infinite set. It is a set that involves an unlimited number of elements. So we have the fourth type of sets. We have the cardinality of the set. Cardinality of sets. The cardinality of sets talks about the total number of elements in a set. The total number of elements in a set. For example, if I have A equal to 1, 2, 3, and maybe 4. So the cardinality of this set is represented by this. So now how do I find the cardinality of set. Don't forget, cardinality of a set shows the total number of elements in that set. So now these are the elements in the set. Okay? So if I want to find the cardinality of this set, I will have to count 1, 2, 3, 4. So 4 is the cardinality of this set because the number of elements in this set is a total number of 4. This is 1, 2, 3, 4. So the total number of elements in this set is the cardinality of the set, which is 4. Let's try this another number. Let us use A equal to 3, 5. So that the cardinality of this set, let's say, since we've used A here, let's try using B. So the cardinality of B of this set will be, I'm going to count 1, 2. So 2 becomes the cardinality of the set. That's the total number of elements in that set. So here becomes 2 as the cardinality of the set. The next set we are going to be looking at, which is the fifth set, is the subset. Subset and the superset. The subset and the superset. The subset of A, or A is said to be a subset of B if the numbers or elements in A are also contained in B. For example, if I have A to be equal to 1, 3, 4, and then I have B to be equal to maybe 1, 3, 5, 6. Alright. So now, if I am asked to find the subset of this expression or of this set, if I am asked to find the subset of this set, don't forget, a subset of any set or a subset of A involves or defines the number of elements contained in A that are also in B, which means that what numbers can we find in A and also find them in B? That is what it means. So now if I want to represent a subset, it is being represented by so now this is A subset B, which means that I'm going to look for the number you are seeing here in A in set A, and also check here if you see the same number in set B. If eventually you see the same number in set B, then A becomes a subset of B. So now I'm going to list out those numbers I'm seeing in A because A is said to be a subset of B if the numbers found or the elements found in A are also in B. So now I have 1 in A and I have 1 in B. So this is 1. I have 3 in A. I also have 3 in B, which is 3. I have 4 in A. Well, I don't have 4 in B. Alright? I have 6 here. And there is no 6. So this means that this is automatically the subset of the set. So A is a subset of B with this. Alright? Because this number and this number are being found in this set B. Alright? And if A becomes a subset of B, then B will have to become a superset of A. A superset of A. Right? So that's what it means. That's what it means. We have the number 6 type of set. Which other set? We have complements of set. Complement of sets. So now the complement of a set is a set that is a universal set but are not in A. Okay? The set of numbers or elements in the universal set but are not in A. What that means is that if I have a universal set U, it's being denoted with this. This is a universal set. Is equal to let's say 1, 2, 3, 4, let's stop at 5. And I have a set A. One, two. So now don't forget, the complement of the set is the set of the universal, or is the universal set, the elements in the universal set that are not in A. So now I check here, don't forget, is the number of the elements in the universal set that are not found in A. So I have 1 here. In the universal set, 1 is found in A, 2 is found in A, 3 is found in A, but 4 and 5, they are not found in A, which automatically means that A complement, which is indicated or represented in this format, will be equal to those numbers that are not found in A, which is 4 and 5. But note, comma is always used in separating elements in the set. Comma is always used in separating elements in the set. Don't forget. And then we also have I will show you why comma is important in separating sets or elements. So now, we have number 6. Let's take number 7. The singleton set. Singleton is a type of set. The singleton set. Now this set involves a set having just one element. Like the name implies, single, one, uni. Alright? So now the singleton set is a set which involves only one element. For example, if I have A, 2. This is a typical example of a singleton set. But A is equal to, let me say, 2 and 3. This is not a singleton set because it contains or has more than one element in it. So this is an example of a singleton set. So now, if I remove this comma from here, I have 23, and this makes it a singleton set. But if I include the comma, it separates 2 and 3, which makes it different. Which makes it this is having 2 elements in it, and this one has only one element. So this first one is a typical example of a singleton set. So take note of that. And then we have the number 8 to be difference of sets. Difference of sets. Now the difference of sets, let's say the difference of A and B is denoted by or represented by A minus B. So now what this simply means that this is a set of elements that are found in A but are not found in B. Alright? These are set of elements found in A but are not found in B. For example, if I have A equals to 2, 3, and 6, and I have B equal to 3, 4, and 6. So now, don't forget, it is the number of sets or the elements found in A but are not found in B. That's the difference of sets. What if I have B minus A? It will now be the elements found in B but are not found in A. So now I have two typical examples. I have 2, 3, and 6. And I also have 3, 4, and 6. So if you check where here, 2 is in A, but it's not found in B. Alright? So now let's take down that. The difference of A and B. The first one we have 2 is found in element A, in set A, sorry, but it's not found in B. So I have 2. 3 is found in A, but it's not found in B. Oh, sorry, 3 is found in B. It's found in B. This is 3 and this is 3. So 3 is found in B and also found in B. So we don't write it down. There is no 4 here. We have 6 and we have 6. So this simply means that the difference of this set is 2. So that's what it means. The difference of this set is 2. And we have the universal set. The universal set. The universal set is the number of all possible sets. For example, we have A to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is a typical example of a universal set. Alright? This is a universal set. This is a universal set. And then we are going to be looking at the number 10, disjoint. Disjoint sets. You know when something is disjoint, it's when they are separated. So if I have 2 sets, let me say A and B. The disjoint set is a set that has its elements not found in A, neither in B. So what this means is that if I have A to be equal to, if I have A to be equal to 1, 3, 4, and I have B to be equal to 2, 6, 5. This is a disjoint set. It is an example of a disjoint set because the elements found in A are not in B, and the elements found in B are not in A. So the two sets are not having anything in common. So now we are going to dive into the basic operators, basic set operators. Basic set operators. Number 1, we are going to talk about the union set. Union set. Union set. This union set talks about the combination of set A and set B. Or you can say it is the set which involves the combination of the elements in set A and the combination of the elements in set B without repeating. For example, if I have A to be equal to, I have the numbers 1, 2, and 3. And I also have B to be equal to 3, 4, and 6. Don't forget, union set talks about the elements, the combination of the elements in set A and set B. So the union set, which is represented by A union B unity, uniting. So it will be this. Don't forget, without repeating, we have 3 here, I have 3 here. So you take only 1 3. I'm not going to put down 3 3. Alright, so I have 1. I have 2. I have 3. I have 4. And I have 6. And then lastly, we are going to look at the intersections of sets. The intersections of sets. Under set of vectors, we are going to look at intersection of sets. So the intersection of sets is the set which involves the element of, or you can say, it is that element that is common between set A and set B. What I mean is, if I have A to be equal to 2, 3, 4, 6, and 10, and I have B to be equal to 1, 3, 4, 8, and 7. So now what this intersection of sets is talking about, that number or element that you will find here and also find here. You will find that number here and also find here. That number becomes the intersection of that set. So it is represented by A intersection B. A intersection B. Alright? So now I have 2, I have 1, I have 3, and I have 3. So 3 is common here. 3 is in A and also in B. So I'll have 3. I have 4, and I also have 4 in B. So I'll have 4. I have 6, and this is 8. They are not common. I have 10 and I have 7. They are not common. So my intersection of A and B is 3 and 4 because 3 is found in set A and also found in set B. 4 is found in set A and also found in set B. So far, we've talked about the definition of sets, how sets are being represented, types of sets, and basic set operators. If you watch very well, we skipped one of the type of set, which is the power set. So in our next video, we are going to be talking about the power set. We are going to be talking about the power set and as well as the Venn diagram. Don't forget to like this channel, share this channel, and also subscribe to this channel. Share your thoughts in the comment section. I'll see you in the next video. Thank you.